Problem number 21. Calculate the oxidation state or oxidation number of the underlying atom in the following species. A. CrO5. In CrO5, what's called this is the peroxide form. And here, even though there are 5 oxygen atoms are there are some peroxide linkages. The structure is Cr, this O, oxygen. Oxygen is the peroxide linkage, and here also oxygen, peroxide linkage, and this is the correct structure. And for peroxide linkages, the oxygen atom having the oxidation state -1. So -1, -1, -1, -1, -4, and for this -2. So total -6. Therefore, for chromium it must be +6. Therefore, +6 is the oxidation state of this chromium. Now come to the second one, B, O2F2. This is the oxyfluoride. The fluorine always takes -1. Therefore, the two fluoride ions in total gives -2. So that must be compensated by +2 here. So +2 is shared by 2 oxygen atoms. Therefore, for oxygen, here the oxygen number is positive, that is +1. So +1 oxidation state is exhibited by that oxygen in O2F2 compound. So this is one of the compounds in which oxygen atom exhibit positive oxidation state. Now C, xenon O6 4-, this is the percyanate ion, and here xenon exhibit +8 oxidation state. Here O6 oxygen atoms, therefore -2 into 6, so -12. Here -4, that is net result because sum of oxygen number is equal to -4 here. So X plus here -12 must be equal to -4. Therefore, for xenon it should be +8. So +8 it is exhibited by xenon here. And D, KO2, this is the superoxide, and here potassium always takes +1, and +1 is shared by 2 oxygen atoms. Therefore, here the oxidation state of oxygen must be -1/2. And now that next compound, this is a complex compound, potassium ferric cyanide. So outside the complex ion is this +3. So the entire complex ion is -3, and -3, here each cyanide ion -1. Therefore, -6 plus X must be equal to -3, or Fe, the oxygen state, is +3. So here ferrous ferric ion is in ferric form, +3 oxygen state. Therefore, we can write like this also, Roman numeral. And next compound, potassium permanganate. Here manganese, 4 oxygen atoms, there is -8 here, and here +1 to compensate, because sum of oxygen number is equal to 0. Therefore, manganese must exhibit +7. So +7 is the answer. And G, NaH2PO2, sodium hypophosphate. For sodium, if it is +1 and 2 oxygen atoms, this is -4, and 2 hydrogen atoms +2. So +3 -4, and this must be +1. Here the correct answer is +1. Then pH3, this is a non-metallic hydride. Here oxygen exhibit +1 oxygen state. Therefore, +3 for the 3 hydrogen atoms. Here it must be -3 for that phosphorus. And H4P2O7. So 7 into -2, so -14, and +4. So net result +10. +10 is shared by 2 phosphorus atoms. Therefore, for each phosphorus is +5. And last, chloroform, CHCl3. And Cl is more electronegative element, -1. Therefore, -3 for the 3 chlorine atoms, and hydrogen +1. Therefore, the net result +2 here, because sum of oxidation number must be equal to 0. For carbon, the oxidation state is +2. So all the oxidation states are mentioned here. And while doing the calculation in compound, neutral compound, the sum of oxygen state of all atoms must be equal to 0. In the case of ions, the sum of oxidation number must be equal to the net charge on the ion. So go by the rule, and as a general rule, fluorine always exhibit -1 oxygen state, and all other elements exhibit variable oxygen state. Therefore, while doing the calculation, you have to follow certain general rules. Oxygen generally exhibit -2, except in peroxide. In peroxide it is -1. In oxyfluorides, positive oxygen state for oxygen. Fluorine, as I told you, always -1. And zinc, metal like zinc, always exhibit +2. There is no other variable oxygen state. And all other elements can exhibit many oxygen states depending upon the situation.